Now let's look at how to use the t-distribution for confidence intervals for the mean when the population standard deviation is not known. Number 5 is a warm-up. Find the critical t-value for a 95% confidence interval when the sample size is 22. So essentially, if we draw a picture, t-distribution looks a lot like a normal. 0 is our mean. This 95% means that we need to find the t alpha over 2 value here so that the area in the tails adds up to 5%. So this is 0.025 area, and this is 0.025 area. And the positive t value, this is going to be a negative t value. That's the same absolute value. T-distribution has degrees of freedom, so we need to find the appropriate degrees of freedom for this t-distribution. When we're working with means, the t-distribution has a degrees of freedom defined to be the sample size minus 1. Our sample size here is 22, so 22 minus 1 means our degrees of freedom is 21. 95% and these 0.025s in the tails, these are areas. And when we are given areas, we need to use the t-inverse function. Now, particularly, I want the area to the left of this positive t value. But if you notice, when I color in this picture, I'm picking up half of the 5% that's left over from that 95% confidence interval. So the 95% is referring to the amount here in the middle between these two values, with that 5% being split between the two tails. That ultimately means that at this t value and to the left, the area is 0.95 plus 0.025, 0.975. Now this won't affect us too much when we apply the template because the template will take care of this calculation, but I want to make sure that you have a visual for what these confidence levels mean in relation to the distribution, how we end up using the 0.975 instead of 0.95. We're splitting off that 5% on either side in the tails, but when we work with the calculations in Excel or Google, they want all the area to the left. So we have to come back and pick back up this 0.025 on the left, add it in to get the right value. So we'll do a t-inverse function. Our area is 0.975 and our degrees of freedom are 21. So this is the command that we're going to put into our spreadsheet. The same whether you use Google or Excel. And so I'm just adding another spreadsheet onto my template. You can do it anywhere, it doesn't really matter. So we'll type in t.inv 0.975 and 21, and we get our t critical value 2.0796, 2.080 if we were to round to 3 decimal places. And so we'll put that right here. That would be our critical t-value for a 95% confidence interval. Taking a look at the next problem, we have some gasoline taxes here. A random sample of state gasoline taxes in cents is shown here for 12 states. Use the data to estimate the true population mean gasoline tax with 90% confidence. Does your interval contain the national average of 44.7 cents? So we have data that I'm going to enter into my template, and we have a 90% confidence interval. So if I come back over here to our mean template, go back to the first sheet, I'm going to delete the data from our previous problem that we had. We don't have a population standard deviation right now. And I just realized there's a small mistake on this. That should be a sigma, not an S. So I apologize for that. We don't know that, so we're going to delete it. Right here in the data column, we'll type in our values for the state taxes that are given. And notice we've provided data, so the template's going to compute X bar, S, and N, and we see that here, X bar, N, and S. Our critical t-value right now is set at a 95% confidence level. we want a 90% confidence level. So we'll change that to 0.9. Notice our critical value decreases. We don't need a bigger interval because we have a lower confidence. And our standard error, our margin of error is 2.5, so we have 2.5 cents would be our margin of error. And then we have our lower confidence limit and upper confidence limit. So between 20.67 and 25.73, since our data has 1 decimal place, we'll take it out to 2 decimal places. And we are assuming normality here. Since our sample size is so small, we are definitely assuming that this is a normal distribution already. We have our data. We don't know anything in the front. Since we just have the data, we put in our confidence level. It calculates all of the requisite values that we need. We've got our critical value here, 1.7958, standard error, margin of error, and then our confidence levels, or our confidence interval here. So 20.67 to 25.73. A side note, if you're working out a problem like this on a test, I do want your sheet, your spreadsheet file. So I want to see exactly how you set up the template every single time, which means you'll have to practice copying that template. Sometimes copying a spreadsheet like this is a little finicky, depending on the setup of your operating system, your computer, what have you. If you're finding difficulty on one platform, switch to the other. So if you're finding difficulty copying and pasting in Excel, switch over to Google and copy and paste in Google. A lot of times, because Google is browser-based, it doesn't have the same issues that Excel has, particularly if you're using an Apple product with Excel. If you're using an Apple product and you're trying to copy and paste in Excel and it's not working, switch over to Google. So you should be able to switch over to a Google sheet if the Excel product is not working. And again, for each of the problems that you're using the template on, just copy the template over either into the same sheet. You can copy it, next to the other one. Make sure you number them so I know which problem is which. That would be totally fine. And remember, the ultimate goal is the interpretation. So here we have a 90% confidence interval. So we could write this. We are 90% confident the true population mean of gas tax is between 20.67 cents and 25.73 cents. So that would be the first step. And then the next question, does your interval contain the national average of 44.7 cents? No, not even close. 44.7 cents is almost double what we have in this confidence interval. So what does that mean? We have a 90% confidence interval. It's really far off from our national average of 44.7 cents. Well, this could mean a couple of things. It could mean that we just happened to get the sample of gas taxes that severely underestimated and missed capturing that national mean. So it could be one of the 10 out of 100 that's not going to capture the mean. It could be that this random sample wasn't so random. Even though it says it's random, maybe it's not. Maybe they were picked from mostly lower cost of living areas, providing a lower tax and then thus giving us a lower estimate. It does not mean that we're wrong. It just means that our confidence interval didn't capture it, and we would want to take another sample. So we would go out and gather another random sample of state gasoline taxes and see if we could capture it again with a 90% confidence interval. 2 more problems here to look at, and I realized that my number 8 has no data. Apologies for that. So we're going to scratch out number 8. And again, completely random mistake here. So number 8 is going to disappear. There's no data, data are shown below. I guess I forgot to copy it over. So I'm going to erase it so we have more room for number 7. Apologies for that. Okay, so number 7, 10 randomly selected people were asked how long they slept at night. The mean time was 7.1 hours and the standard deviation was 0.78 hour. Find the 95% confidence interval of the mean time. Assume the variable is normally distributed. So we have 10 randomly selected people. The mean time was 7.1 hours. Is that a population mean or a sample mean? It's referring to the sample, so that's a sample mean. The standard deviation was 0.78 hour. Population standard deviation or sample standard deviation? Right, sample standard deviation. It's referring to that sample of 10 people. And we want the confidence level to be 95%. So let's flip over to our template again. We need to delete the data so that it's not present and input what we know. So we know our sample mean, 7.1. We know our sample size is 10. And we know our sample standard deviation, 0.78. Our confidence level is 0.95. And notice it's repeating the values from up here. So if we enter our sample mean, our sample size, and our sample standard deviation in yellow, it repeats them down here for the calculations. This is because of the flexibility of the template, allowing us to either put in the data, which it will then calculate down here, or enter the statistics, which it will just copy. If you look at the commands up here, it's doing a little bit of computing in the background. So if the range count is greater than 0, so range is defined to be this column A, where we would put the data, and count counts how many values show up in the cells. So how many different cells have something in them. And then if that count is greater than 0, then the sample size is just that value, the count. If there's nothing there, meaning that the count is 0 in that range, then it copies D6. And you see D6 right here is our sample size. So it's doing a nice little tiny bit of computing in the background. If you're looking at these different statements that show up, you'll see if statements. And this is just allowing us to have flexibility in our template. All right, so now we have our template set up. I'm going to first zoom out just a little bit and grab a snapshot. And we can see that our confidence interval is 6.5 to 7.7. So we'll write that out. 6.5 less than mu less than 7.7. And then we interpret that by saying we are 95% confident that the true mean time of people sleeping at night is between 6.5 and 7.7 hours. With a different sample or a bigger random sample, we might get a better estimate, and that's typically the case with statistics.